Okay, hello everyone. Woo! 18.1 is a doozy. I agree. Hard section. What's nice, 18.2 is a cakewalk compared to 18.1. So I know this is going to sound crazy, but let's have some fun with some math. So today we're going to talk about the quadratic formula, all right? It's not difficult. So the quadratic formula. So first thing you got to have is a quadratic equation, all right? So you need to start with ax squared plus bx plus c equals 0. All right. The key here is you got to set it equal to 0. All right. Now, the quadratic formula, and you know what I was going to do? I was going to prove the quadratic formula for you, but what I'm going to do here is this instead. I'm going to send out an email in Blackboard, and I'll make it worth bonus points for you to prove the quadratic formula for me. All right. So what I mean by that is this. All right. So here's your bonus problem, okay? Starting with ax squared plus bx plus c, derive the following. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this, ladies and gents, is our quadratic formula. All right? So the bonus problem is you're going to start with ax squared plus bx plus c, and you are going to algebraically manipulate it to get x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay? Now, you cannot use numbers. You have to use the letters A, B, C, and X. All right? Now, there is a lot of special things that are happening inside this quadratic formula. All right? One of the most important is right here. So I'm highlighting it in blue, okay? And that is called the discriminant, okay? So let me draw a little arrow, and that's called the discriminant. All right. Now, why is that so important? Well, the discriminant tells us the types of solutions we can get from our quadratic equation. All right. So, at the beginning of the semester, we spoke about linear equations, okay? And more importantly, we spoke about systems of linear equations. And if you recall, with systems of linear equations, we actually could arrive to 3 different types of solutions. We could arrive at a solution where the 2 lines cross, they intersect, okay? We would call that consistent and independent, all right? The second type of solution would have been 2 parallel lines. All right, let me write these out here. So recall, I do this too much. Recall from systems of linear equations. If we have 2 lines that cross, all right, so let's say line 1, line 2, they cross right there, we would say that is consistent and independent, okay? Then we had the situation where you had 2 lines that were parallel lines, okay? And then we would say, well, there's no solution there, all right? And then the last, the last type of solution we could have would have been 2 lines that are literally on top of each other, okay? And we said that that was still consistent, all right? We said that was consistent. However, it was dependent, okay? Well, the discriminant tells us the types of solutions that we can get for quadratics. So I'm going to introduce you to the types of solutions first, all right? So if b squared minus 4ac is bigger than 0, okay, then you will get 2 real distinct solutions. Okay? Sometimes you call this solution roots, but you're not going to hear that word until you take pre-calc or calculus, okay? So you're going to get 2 real distinct solutions. Now, what does that mean? Well, that means that if I were to graph this, okay, so I'm just going to graph. There's my quadratic equation graphed. And if you notice right here and right here, that's x1, that's x2. Notice they are real numbers, okay? So they are real numbers. And they are different. And another way to say different is distinct. All right? Okay? So that's if your discriminant is greater than 0, okay? So that's honestly number 1. That's your first type of solution. Your second solution is if b squared minus 4ac is actually equal to 0. So if b squared minus 4ac is equal to 0, then you will have one solution that is repeated. Okay? So what does that mean? Well, let me show you. Here's our quadratic. We're going to graph it. And notice it only hits our x-axis once. Okay? It hits at the vertex. So what we call this, we say that, this is going to be x1. So x1 equals x2. In other words, they're repeated solutions. All right? And we will see problems like that, okay? Now we have one more type of solution. One more type of solution. So if you think about it, if you've been paying attention, maybe you can guess it. Step 1 or solution 1, it was greater than 0. Your discriminant was greater than 0. And 2, your discriminant was equal to 0. So what do you think the last one is? If b squared minus 4ac, what do you think? Hopefully you thought less than 0. So if b squared minus 4ac is less than 0, then you will get complex conjugates. All right? So let me show you what that looks like. All right? So here's our graph. Here's our quadratic. And notice this does not go through the x-axis whatsoever. It does not go through the x-axis at all. Okay? When that happens, you are going to get your solutions, x1 will equal a plus bi, and your second solution will be a minus bi. Because you have to remember, complex numbers always exist. Oh, I can't spell. Come on. Conjugate pairs. All right. Now, in terms of like theory, that's it for today. All right. What we're going to do from here on out, we're just going to start doing we're going to do examples. Okay. And I will identify every single one of these situations for you. All right. So, all right, here comes the fun part. Like I said, this is going to be fun. 3x squared. Let me write solve. 3x squared minus 5x minus 2 equals 0 for x. All right? So sometimes it's extremely beneficial to find your discriminant to see or to give you an idea of what your solutions should look like. Okay? So let's label. A equals 3, B equals -5, C equals -2, okay? We know the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And the most important part is to do proper substitutions. So let's find our discriminant. We get b squared minus 4ac. So that's going to be negative 5. Notice how I put it in parentheses. Minus 4 times 3 times negative 2. Negative 5 squared is 25. And then we get, I don't want to write that yet. Negative 4 times 3 is going to be negative 12. And negative 12 times negative 2 is going to be positive 24. So 25 plus 24 equals 49. And since that is bigger than 0, I know we're going to have two real distinct roots, or two real distinct solutions. And I know if I were to graph this, it would cross the x-axis twice. So not only am I going to do the quadratic formula, I'm also going to graph it for you, okay? X equals negative parenthesis, make sure you put the parentheses here, negative 5, plus or minus the square root. Well, since we've already calculated the discriminant, we can just put the square root of 49 there, okay? All divided by 2 times 3, okay? So that's going to give me x equals 5 plus or minus 7 all over 6. And what I like to do here is separate. I like to separate. So I'm going to write x equals 5 plus 7 divided by 6, or x equals 5 minus 7 divided by 6. Okay? So I'll do a little line. I get x equals, for my first solution, x equals 5 plus 7 is 12 divided by 6, or my first solution is 2. And then for the second, I get 5 minus 7, which is going to be negative 2 over 6. And then when you reduce that, you get x equals negative 1/3. Okay? Now, as a decimal, this is approximately negative 0.333 repeating. Now, the reason why I wrote that is because I told you I'm going to graph this for you. All right? So remember, what we're expecting here is this. We are expecting to go through negative 1/3. So if this is negative 1, I'm going to say that's negative 1/3. And 2. And we're expecting our quadratic to look something like that. Okay, let me write this a little nicer. There we go. Okay, so this is what we are expecting, all right, our graph to look like. So what I'm going to do is I will open up Desmos. All right, so here's our graph, all right? And what I'm going to do is put it in projector mode. And I'm going to click on my intercepts. Negative 1/3, or negative 0.33333, and x equals 2, okay? So what I'll do is I'll copy and paste this into our notes. So I'll use my snipping tool, new, and then I'm just going to highlight what I need. And that is exactly what we were expecting to get. Okay? There it is. All right. So now what I'm going to do is we are just going to just start hammering out some problems here. Okay? So let's look at one where the solutions aren't that nice. How about 3x squared minus 8x equals 2? Okay? Well, you got to recall, we need it in the form ax squared minus bx, or ax squared plus bx plus c equals 0. In other words, we have to set this equal to 0. So to do that, I'm going to subtract 2 from both sides of my equation. 3x squared minus 8x minus 2 equals 0. Let's find out what our solutions are going to look like. Let's find out what that discriminant looks like. So a equals 3, b equals negative 8, c equals negative 2. So I get negative 8 squared minus 4 times 3 times negative 2. We know negative 8 squared, well, that's going to be 64 minus 4 times 3 is 12 times negative 2 is going to be positive, what, 24? And 64 plus 24 is going to be 88. All right. So I know I'm going to get real, distinct solutions. All right. All right. Here comes the fun part. Quadratic formula time. So I get negative 8 plus or minus the square roots. We've already done the discriminant. So I put square root of 88 divided by 2 times 3. All right. So that's going to give me x equals 8 plus or minus the square root of 88 all over 6. Okay. So now what I have to do is simplify. So I'm going to separate like I normally would. So x equals 8 plus the square root of 88 over 6, or x equals 8 minus the square root of 88 over 6. All right? So draw my line. And what I got to do now is just simplify. So x equals 8 plus, let's simplify the square root of 88. So we know the square root of 88 is really what? 4 times 22, I think, is what we want. Okay? So that's going to give me x equals 8 plus 2 square roots of 22 all over 6. And then I can reduce to give me x equals 4 plus the square root of 22 over, what do you think, 3? And there's my first solution. Now the second one, x equals 8 minus the square root of 4 times 22. That's going to give me x equals 8 minus 2 square root of 22 all over 2. Or I'm sorry, all over 3. For a final solution of x equals 4 minus the square root of 22 over 3. Okay? So here we have an example of very ugly solutions. Okay? Really ugly solutions. All right? So let's keep doing this. Okay? Let's keep going. All right? How about a problem like this? Let's really switch this up. Okay? So how about 1/4 m squared minus m plus 1/2 equals 0? Okay? Now, if we wanted to, we could go ahead and use a quadratic formula on this. And I'm going to write it out. You don't have to write this out, but I'm going to write it out to show you what it would look like. And I can already hear what you're thinking in your head, which is, I hate fractions. I don't want to do that. So why not just make this problem a little easier for us, okay? Instead of doing this problem, why don't we just find an LCD, multiply the entire equation by it, and that will simplify the fractions. So when you look at the denominators, 4 and 2, hopefully you can see that we're going to multiply everything by 4. And by doing that, that gets rid of all of our denominators. So 4 times a fourth, that's going to be m squared, minus 4m, plus 4 times a half, well, that's 2, and that equals 0. Now, from here, you can just go right into what you need to, all right? So a equals 1, b equals negative 4, c equals 2. Let's find our discriminant. All right, so that's going to give me negative 4 squared minus 4 times 1 times 2. Well, that gives me 16 minus 8, which is 8. Okay? So it's positive. Real distinct roots. That's perfect. Real distinct solutions. Okay? So x equals negative 4 plus or minus the square root of 8 all over 2 times 1, which equals 4 plus or minus the square root of 8 all over 2. So now let's separate. X equals 4 plus the square root of 8 over 2, and x equals 4 minus the square root of 8 over 2. Okay? So now we're just going to simplify. X equals 4 plus, well, the square root of 8 is the square root of 4 times 2, which is going to be 2 square roots of 2. Okay? So that's going to give me 4 plus 2 square root of 2. And then I can simplify that into 2 plus the square root of 2. For the other solution, I get x equals 4 minus 2 square roots of 2 all over 2, or simplified, x equals 2 minus the square root of 2. Okay? And there are the solutions. Not too bad. Okay? So what I want to do here is I want to do one more. Okay? We're going to do one more example here. X equals negative 3x squared minus 3. Okay? So we're going to do this just like we did any other problem. We're going to set it equal to 0 by subtracting both sides by x. That's going to give me 0 equals negative 3x squared minus x minus 3. Okay? Let's find our discriminant. So b squared minus 4ac. So that's going to give me negative 1 squared minus 4 times negative 3 times negative 3. So that gives me 1 minus 36, which is negative 35. So here we can see that discriminant is negative. So I know I'm going to get complex conjugate solutions. Okay? So x equals, now we're just going to use the quadratic formula. So x equals negative 1 plus or minus the square root of negative 35 all over 2 times negative 3. Okay? So that's going to give me x equals 1 plus or minus. Now let's simplify the square root of negative 35, and that's not that difficult. That's going to be I square root of 35 over negative 6. So our two solutions, negative 1/6 plus I square root of 35 over 6. That's your first solution, or negative 1/6 minus I square root of 35 over 6. And there is our second solution, okay? And that's going to be it for this section. So I will see you in the next one, which is literally taking everything that we've learned and just solving problems, okay?